Let's start by reviewing a few electrical terms. We'll be talking about electrons moving about, so let's note a few properties. Electrons have charge. An object with charge has an electric field associated with it. This field is the force of attraction or repulsion that some other test charge would feel if it came into the neighborhood of our electron. Often we need to compare the electrical energy of different localities within a system. Imagine that we have 2 points A and B for which there is a different distribution or arrangement of charge. If we were to move a test charge from outer space to point A, some energy would be required to overcome any net repulsive forces, so work would be done. If the net forces were attractive, some energy would be released. Because the net arrangement of charge is different at point B, a different amount of energy would be consumed or released in moving a test charge from outer space to point B. So a difference in charge distribution implies a difference in energy for moving a test charge from A to B. The electrical energy required or gained per charge is known as the electrical potential energy difference between the 2 points, or potential for short. The potential is also called a voltage. The voltage difference between point A and B is the difference in the amount of work bringing a test charge or a unit of charge to these different points A and B. And it has the units of joules per coulomb, coulomb being the unit charge in physics. Of course, in chemistry, we often measure quantities in terms of moles. So 1 mole of electrons has a charge of 96,485 coulombs. Current is the rate of movement of charge, and we might consider the movement of charge past a specific observation point. It is the rate of change in charge per unit time. And we use the letter I to symbolize current in equations. And it has the units of coulombs per second. 1 coulomb per second is also known as an ampere, or amp for short. We often integrate the current with respect to time in order to get the charge, since charge is related to molar quantities of reactants. And that is approximately equal to the average current times the time. Electrical energy is work required to move charges, and it is calculated from the work per unit charge, or the voltage, times the number of charges moved. And that's approximately equal to the voltage times the average current times the time over which we monitor the current. Sometimes we're interested in expressing the electrical power for a system. Power is energy per unit time. So one can calculate that as the voltage times the charge divided by the time, or the voltage times the average current. Power is measured in watts. 1 watt is 1 volt times 1 ampere.